In this video, we're going to learn how to convert between different units of measure using rational expressions or fractions. So our first question is one that you probably know the answer to. If you don't, that's okay though. It says, how many inches are in 4 feet? So if you don't know, there are 12 inches in 1 foot. So I'm going to show you how we can convert units here. So in this case, notice that we're starting in feet, but we would like to go to inches. So for simpler ones that you're familiar with, you may be able to just do that very quickly in your head. So some of you may already say, well, I know that's 48 inches, right? And that's great. But for the harder ones, or the ones we're not as comfortable with, there's a nice strategy we can use to help us figure that out. So what I'm going to do is I'm going to put here what I'm starting with. And again, there's different ways you can do this, but this is one way to do it. So I'm starting with 4 feet, and I would like to get to something in inches, right? So what I need is some sort of ratio or rational expression that relates feet and inches together. And the one that I have is here, that 12 inches is the same as 1 foot. Now, what you want to do, the way you want to use this ratio or this rational expression is you're going to multiply it and you're going to set it up with the unit that you're trying to go to on top. So notice I'm trying to go to inches here. So I'm going to use the 12 inches on top. And the unit you're trying to cancel is going to go on bottom. All right, so this is the unit we want to cancel out. The other thing you're going to notice to make sure that you did actually do this correctly is you should see for the unit we're trying to cancel that that unit appears on top and on bottom. So like when we're simplifying fractions, right? As a little side note here. Right? If I had 4/6, then I could write 4 as 2 times 2, and I could write 6 as 2 times 3, and I could cancel those 2's in common, right? So as I'm simplifying fractions, we can cancel what's in common. Well, we actually can do the same thing with units, which is pretty cool. So here, if I have one unit that says feet or foot on top, and then one that says feet or foot on bottom, those units will actually cancel themselves out. And then you'll notice that the units that we're left with would be the inches. Now what happens is everything else multiplies across. So here I have a 4 times 12, which is 48. On the bottom, I just have a 1. And of course, 48 divided by 1 is just 48. So our answer here is 48 inches. All right, let's try a couple more. So here we're going between square feet and square yards. Now this may be a unit that you're not as familiar with, right? So as a side note here, 1 square yard is the same thing as 9 square feet. So I'm going to start with what I have. So I have 18 square feet. And my goal is to get to something in square yards. So the ratio that relates yards in or square yards and square feet is this one right here. And again, the unit that I want to cancel is going to go on the bottom, and the unit that I want to keep is going to go on the top. So I'm going to multiply by 1 square yard over 9 square feet. Again, notice that those units should cancel appropriately, 1 on top, 1 on bottom. And then you're going to multiply just straight across with what's left, or you could cross cancel if you want to. 18 times 1 is 18, 9 on the bottom. So my answer here would be 2 square yards. That can also be abbreviated like this, 2 yards squared. So sometimes we'll use the actual square in mathematics as well. And same thing with feet. You could also abbreviate this here, for instance, as feet squared. So if you see that in mathematics, just a different way to write square feet. All right, so same idea here, converting between square yards and square feet. So I'm starting with 5.2 square yards. I'm trying to get to square feet. The thing that relates those is this right here, 1 square yard is to 9 square feet. And again, the thing I'm trying to cancel goes on bottom. So in this case, I'm going to put the 1 square yard on bottom and the 9 square feet on top. And that will get the units to cancel that I want to get rid of. So in the top, I have 5.2 times 9, and that is going to give me, actually, let's move this right here, 46.8 square feet over 1, and that is just 46.8. Oops, square feet. Okay, so what you're trying to cancel, you need one of those units on top and bottom so that it lines up correctly. And then the unit you're trying to keep is the one that's left over on top. And this can be applied in all sorts of cases. As long as you know the ratio that relates to units, then you can do this for really any example here. And there's tons of applications for it. There's one more example I do want to do with you guys in this case, or at least one more. Maybe we'll do a second one as well. And I have this one already written out. It says the volume of a particular factory. So remember, volume is 3 dimensions. So you have length, width, and height. So pretend like you sort of have this giant rectangular, or I guess it's not a rectangle, right? But like a box, right? That shape, factory, right? So it is 472,370,319 cubic feet. We want to find this volume, but in cubic yards instead. So the unit they're giving us here is that 1 yard is equal to 3 feet. And you may notice that there's a slight issue because our information is not in feet in yards, it's in cubic feet in cubic yards. So now think of the word cubic. It means to cube something, right? So when you see cubic, because you have 3 dimensions, you're looking at cubing something. So in order to convert this to the correct units, I'm actually going to cube both sides. And when I do that, 1 cubed is 1. So this becomes 1 cubic yard instead. And then 3 cubed is 3 times 3 times 3, just 27. So 3 cubic feet. And you can apply this to other cases. If you know the base form and then you need to square something, or you have square feet or cubic feet, then you can either square or cube it if you don't already have that form. In our last example, do note that the ratio that I gave you was already in square yards to square feet. So I did not have to square anything extra because it was already in that form. Here, though, they've just given us the base version, and I need to cube it because that's what I'm looking for here. All right, so I'm starting with this, 472,37319, and that is in cubic feet. So I'm trying to go to cubic yards. So I'm going to put that cubic feet, cubic, on the bottom. That will allow me to cancel out those units there. And then we're going to multiply straight across here. So 472,370,319 times 1 doesn't change anything. But then I'm going to go ahead and have to divide that by 27 in a second. And the units left now are just cubic yards. Let's see, when I divide that by 27, I get 17,495,197 cubic yards. All right, so let's do one more example here. I'm going to pause the video and come back and for you guys in just a second and have this already written out. Here's our last example now for this video. And the current record for the men's 100-meter track event is held by Usain Bolt, who ran it at an average speed of 34.1 feet per second. And again, this is true at least at the time of this video, in case that changes. We're going to convert this speed to miles per hour. So the speed is given at 34.1 feet per second, and we need to convert this to miles per hour. Now, a couple of things to note here. 1 mile is equal to 5,280 feet, and 1 hour is equal to 3,600 seconds. Now, the mile to feet is something that you can look up online, and that's something that you can find and know. For hour to seconds, what you could do is you could just do 60 times 60. So for instance, to go from hour to minutes first, there are 60 minutes in an hour. And then each minute is made up of 60 seconds. So that's why you have the 60 times 60, because there are 60 seconds in a minute and then 60 minutes in an hour. So that's where that 3,600 comes from. Now, this one is pretty complicated. So this is a couple steps here. So the first thing I need to note is I'm going to write down what I have. So we have 34.1 feet per second. Now, 34.1 feet. Now, when we say per second, there's actually a hidden division there. That word per is division. So this is actually over. And when there's no number, there is a 1. So if I say something like per second or per hour, and I don't give any numbers in there, there's a 1 there. So this means this. So 34.1 feet per second. Okay. All right. Now there's a couple of things we have to do here. Because I need to change both of these units over, right? So I don't want it to be feet per second anymore. I want this to be miles per hour. So I would like my final answer to be like this, miles per hour, right? So I want to eventually get down to something like this, where I have miles on top and hours on bottom. So I have to get some things to cancel here. And I'm going to do this in 2 steps. So it's usually good to cancel just one thing at a time. So the first thing I'm going to do is I'm going to use the feet, right? I do want to have miles up top. So I'm going to multiply so that I can cancel the feet. And I'm going to use this piece right here, right? So I know that 5,280 feet is the same as 1 mile. So by putting the feet on the bottom, this will allow me to cancel with the unit on top, which is feet as well. So now I can see that the miles is coming in. The other thing I want to do here, which is a little bit different as well, is I would like to have hours, but in the bottom. So I want to have some sort of ratio where I can get hours in the bottom, and then I'm going to put seconds on top. The reason is because that way the seconds here will cancel with the seconds here. It doesn't matter along the way if they're right next to each other because it's all multiplication, so everything can be rearranged. But I need seconds on the bottom and seconds on top in order to get that to cancel. So it was 3,600 seconds for 1 hour. And again, notice what's left now for units. Miles is on top, hours is on bottom. So when I do conversions, I have to plan ahead a little bit and think about, okay, well, what do I want my final answer to look like? I need miles on top and hours on bottom. So I want to put my canceling in so that miles is on top and hours is on bottom. If I don't set it up that way, then my answer will be upside down or backwards. So we do have to kind of plan a little bit here as we go through. Now what we're going to do is we're just going to multiply what's left here. So if we look at the top piece, let me get out my calculator here for a second. I have 34.1 times 1 and then times 3,600 here. So I'm going to actually move down here. I have, let's see, 1,22760 miles. And on the bottom, I just have 1 times 5,280. And I'm going to go ahead and do that division out. And I get about, or actually get exactly 23.25. And what happens is when I divide these perfectly, I do get that miles out of 1 hour. Because when I'm dividing here, there is always, I'm dividing this perfectly. So there's always a 1 in the denominator that I could use. So I can convert this back over. And this is going to be 23.25 miles per hour. And we can write it in that notation there, kind of bring it back from the full division to just that per symbol, or you can write the word per as well here. But notice that when we tend to do per, it's usually per 1. So in this case, per 1 hour. So this one, again, a little bit more tricky. So you want to just cancel each unit 1 at a time and really think ahead. What do you want your final answer to look like so that you can set it up so that things cancel in the right way?